Okay, so today's lesson, congruent triangle shortcuts. What we're doing is we're finding ways to prove triangles congruent without having to know like every little part. So we're starting with side, 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 and it's abbreviated SSS. I'm gonna sneeze. Maybe not. Anyways, okay. So side, side, side congruence. So if you know that all the sides of each of these triangles are the same, then you can prove their congruence. So if we know that this side equals this one, and this side equals this one, and the third side is the same as this side, then we can prove that those two triangles are congruent, meaning that all the angles would be the same as well. So that is side, side, side congruence. Okay, and then the other one we're focusing on at first is side angle side, abbreviated SAS. And what that means is if you have side angle side and side angle side, you can prove that those triangles are congruent to each other without having to know all the other parts. Once you prove they're congruent, then you can say that all the other parts are equal, like all the angles are equal and all three sides are equal. But just knowing a side and an angle and a side, you can prove that those are congruent. What's important is that angle has to be the included angle, so when you're naming it, it has to be like in order, side, angle, side, like that. Got it? Okay. Now we're going to look at some examples. It says identify which property will prove the triangle is congruent by side, 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 angle, side, or none. So for number one, you have side, 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 and a matching side, side, side on this one. So you have side, side, side congruence. Those triangles are congruent. For number two, we have side, angle, side, and a matching side, angle, side here. And again, that has to be the included angle, meaning it has to be like in order like that. For number three, remember when I said you had to say it in order? So you have angle, side, side. If you get a cuss word like that, they are not congruent, or you can't prove they're congruent, so none. There is a situation where the ASS one works, but we're not there yet. Okay, then for four, side, angle, side, side, angle, side. So we can prove those triangles are congruent by side, angle, side. Number five, it shows that two sides are the same as these two sides, and it doesn't label the third side, but the third side is a shared side, so it means that it has to be congruent to itself. So then you have side, 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 side. Number six, it has the three angles congruent. Angle, angle, angle. Angle, angle, angle does not prove congruence. They could be congruent, but we can't prove it with angle, angle, angle. Angle, angle, angle only proves similarity. So they're definitely similar, but we don't know if they're congruent. So in this case, none. Number seven, you have two sides in common, and then these vertical angles are the same measure. So because vertical angles are equal, then you have side angle, side, side angle, side. So this one, I feel like I should put a star in this one. These are the two situations where something won't be labeled, but they're still equal. So if they have a shared side, then that shared side is equal to itself. And then the vertical angles are equal to each other, so you can fill that in to get something else, like to figure it out. Then for number eight, side, 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 side. It does have some angles labeled in there, so you might try side angle side, but when you do that, you realize that this is a 1 marked and a 2, and the included angle is right here. And over here, the included angle is between 2 and 3 marks, so it doesn't all match up. So side, side, side would be what would be used there. Number 9, side, side, side. Number 10 is a side and an angle, and remember this shared side is equal to itself. So then you have side, angle, side on both. Number 11, you have matching side, side, side. And then 12, angle, 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 which doesn't prove congruent, so none. Okay, so now we're going to look at some ways that this is tested, or questions that might be asked on testing about this. For 13, it says, what information is needed to prove the triangles below are congruent using side, side, side congruence postulate? Okay, so on A, it shows that two of the sides are congruent. To prove side, 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 we need to know that the third side is congruent to the third side. So we need to know that RG equals CL, or is congruent to, however you want to, we need to know that RG equals CL. Then for B, again, we're still trying to do side, side, side. We can prove that this is equal to itself because of the reflexive property. What we would also need to know is that this side is equal to this side. So AS needs to be equal to CE. What information is needed to prove the triangles below are congruent using side, angle, side? Okay, we have a side and an angle. We need to know that another side is this side is equal to this side. Remember that angle has to be the included angle in the middle there. So side, angle, side, side, angle, side. We need to know that SD is equal to OR. Which pair of triangles can be proved congruent by side, angle, side? Side, side, side. This one has two sides in common, but we can't prove that the third side is in common. So not this one. For B, we have side, angle, side, but it's specifically asking for side, side, side. So not that one. For C, we have side, side, and then the middle side, the shared side, would also be in common. So this has side, side, side. It's probably this one. And then for D, vertical angles are equal. We could prove side, angle, side, but it's looking for this one. Okay, 16. Which pair of triangles can we prove congruent by side, angle, side? So specifically side, angle, side. This one would be side, side, side. Nope. G, we have the shared side. So side, angle, side, probably this one. H has an angle in common, a shared side in common. This is the ASS one, which doesn't prove congruence, so not that. And then this, we don't have enough information. We just have one side and one angle, which wouldn't make them congruent, or we can't prove they're congruent. And what additional information do you need to prove that triangle NOP is equal to QSR? Okay, well, it shows me two sides. Maybe if this side was equal to this side, I could use side, side, side. So if PN was equal to QR, but that answer isn't there. Rude. So let's try side, angle, side. So erasing this, didn't work. So now I'm trying side, angle, side. If I use side, angle, side, this angle would have to be equal to this one. Angle O would have to be equal to angle R. Oh, I put it on the wrong one. What am I doing? Sorry. This one. Side, angle, side. It has to be the included angle. So S. This one. So a little trial and error there. Just test taking strategies. Okay, so now we're going to skip the next page, which is proofs, because we're going to do that on Monday. So we're going to incorporate this in proofs on Monday. But we're just focusing on the concepts here. So we're going to move to, just kind of skip a page, lesson 5.4. I'm going to zoom out here so I can see the page. Okay, so lesson 5.4, we're proving triangles congruent using two more. ASA, which stands for angle, side, angle, and AAS, which is angle, angle, side. So ASA for ASA, angle, side, angle. And then AAS is angle, angle, side. And we'll look at examples with these too. Okay, ready? Okay, so I've been mentioning the word like included. We saw an included angle in the last example, but what is an included side of a triangle? It's the side in between two consecutive angles. So an included side is the side in between two consecutive angles. So specifically this comes up with angle, side, angle. So like angle, side, angle. It has to, this would be the included side. So this right here is that included side. And over here, if you had some kind of situation like that, this, and then this would be your included side right here. The side in between two consecutive angles. Okay, so looking at these postulates, angle, side, angle postulate says that if two angles in the included side of one triangle are congruent to the two angles in the included side of a second triangle, then the triangles are congruent. So if the angle, side, angle matches angle, side, angle over here, then you can say that these triangles are congruent. So let's say this is A, B, C, and we'll call this D, E, F. To name these congruent triangles, which came up in our last lesson, you have to make sure to name them in order. So if I'm starting with this one arc angle and then going to the non-labeled, then C, A, B, C is congruent to triangle D, E, F, and everything has to match. So in this congruent statement, A should equal D, B should equal E, and C should equal F. Okay, then we have angle, angle, side. And this is the last of them, by the way. Angle, angle, side. So that would be angle, angle, side. And it has to be in order. Angle, angle, side. So again, if we had P, Q, R, S, T, U. When we make the congruent statement, we'd have to say, okay, P, Q, R is congruent to, and you have to make sure it's in the same order, S, T, U. So all the parts match. Triangle S, T, U. Okay. And once you know that those triangles are congruent, then you can say that everything else is incongruent, which we'll see in the proofs as well. Okay, so let's practice some of these over here. Can the triangles be proven congruent by side, or angle, side, angle? If so, state which one. Okay, moving in here. Just like we saw in the last examples, if it has a shared side, you know that that side is congruent to itself. So right here, that side is equal to itself. And then in these two triangles, you have angle, side, angle, angle, side, angle. For number 2, it's almost the same exact situation. Angle, side, angle, angle, side, angle. So they are congruent by angle, side, angle. Number 3, the vertical angles are equal to itself. So we can label that. And then we can see if we have any of our congruence postulates. Let's see, angle, angle, side, angle, angle, side. Number 4, it has 2 of the sides labeled, but it doesn't say anything about the third. And we can't prove that those sides are equal, so therefore none. You can't prove that they're congruent. Number 5, we're going to label the vertical angles so that way we can see those. And then you have angle, angle, side, angle, angle, side. Number 6, all 3 angles are the same, but that doesn't prove congruent, so none. They could be congruent, but we can't prove it. And then 7, we have a shared side, and then angle, angle, side, angle, angle, side. Okay, and that is all. Your homework, as you know, is normally only 5 questions, but on this homework, they all look like this, and they're very quick answer, and it's important that you have a lot of practice with this. So there's actually 15 of them, but it shouldn't take you more than like a couple minutes. If you want me to look it over before you submit, just let me know, and you can get a laptop and get started. I'll enable the homework.